Hello and welcome once again to CaptainGoodspeed Maths. Today we are doing some more of the OCR FSMQ new specification, and today we start the statistics part of the course, which starts with permutations. So we've been doing some numerical methods lately. There are a couple more in the textbook, but honestly they're only a couple of lines. If they come up, they come up. I can't imagine they would be that many marks, so I'm not going to bother going through them. If you want to know what they are, have a look at the spec on OCR FSMQ. I'm sure there are other videos on this website. I will probably have them in for next year, but don't have the time really this year, so I'm focusing on the important stuff. So today we are learning how to understand how to work out permutations. So in some situations, such as a race, the finishing order is important. An ordered arrangement of a number of people or objects or operations is called a permutation. So in general, the number of permutations, which is denoted NPR, where usually the P is the big letter and the N is the little one, but I couldn't get PowerPoint formatted properly, but you get the idea. Of R objects from N is given by NPR, which is equal to N factorial over N minus R factorial. Now, if you don't know what a factorial is, basically it is the number times every number before it. So for N factorial, it would be N times N minus 1 times N minus 2, all the way down to 1. And for N minus R, similarly, it would be N minus R times N minus R minus 1 times N minus R minus 2, all the way down to 1. So that is the formula for it. You can learn that if you want, but there's also a button on your calculator. If you have a Casio calculator, the 83 series, which is what I used when I did these sorts of studies, we press the NPR button, which is you press shift and then the multiply button, and you'll see it written just above the multiply sign on your calculator as NPR. So what you would do is you'd type N in first, then you'd do shift times or shift and then press this button, and then you type in R and press equals, and you would get what this would work out. Hope that makes some sense. I do an example in this, so hopefully that'll make it clear. So here's an example then, just the one today. They're all pretty much the same with permutations. So 5 people go to the theatre. They sit in a row with 8 seats. Determine the number of ways in which they can arrange themselves. That's a typo, apologies about that. They can arrange themselves in the row of 8 seats if 1, they can sit anywhere in the row, or 2, all the remaining empty seats are next to each other. So the first person has a choice of 8 seats. Then the second person has a choice of 7 seats. Then the third person has a choice of 8 seats, etc. The number of arrangements is therefore 8 times 7 times 6 times 5 times 4. Yeah, so the first person has 8. We then multiply that by the second person who has 7. Then the third person who has 6. The fourth person who has 5. The fifth person that has 4. Everybody has a seat now. So 6,720 ways that these 5 people can sit in these 8 seats. That is a completely baffling statement, in my opinion. This is a permutation of 5 objects from 8, so 5 people from 8 available seats. So a quicker way to do this would be to type 8, then NPR, then 5 on our calculator, and we'd get 8p5, which is 6,720. So the next bit isn't actually animated on the PowerPoint, but I will save the little ink bit that I do so that you guys can see that on the uploaded PowerPoint. I do apologise about that. But part 2, so all of the remaining empty seats are next to each other. So basically what that means is these 5 people want to sit next to each other, and the 3 remaining seats are going to be a block of 3 either side of these 5. So basically, you can imagine those 3 seats as one seat, one big seat. So we've actually now got 6 seats to consider. So we've got 6 if I can write. Oh my goodness, that's big. 6 seats, and we've got 5 bums to sit on them. So 5 objects, and then we just type that into our calculator. So we've got 6 seats and 5 objects. So let's do 6p and then 5 on our calculator. So I'm doing this live, so I type 6, then shift, then times, then 5, and I get 720. So there's 720 possible permutations of the way those people can be sat on a certain number of seats, which again is completely baffling. But that is everything to do with permutations. Hopefully you found that helpful. If you have, then make sure you leave a like down below, and if not, then let me know what I can do in the future to make it a little bit more clear to you. As always, this lesson will be in the description with this little bit of ink on it, and hopefully by next year I'll have sorted it out, but knowing me, I probably won't have, but hey ho. But yeah, Tuesday's exam's coming, and best of luck for it.